Our next lesson is on wind energy and the basics behind how we use wind energy. Wind energy is the fastest growing of all the renewable energies in the United States and probably around the world. Here we got a renewable energy that has very, very little environmental impact. The idea here is to turn a turbine and which turns a generator without burning any fuel. So we don't have to turn water into steam and steam to run the turbine. In this case, you're taking the energy directly from the wind and spinning the turbine. So hopefully it'll be better overall from an environmental perspective. All right, when you look at wind energy, you want to understand that you're taking the kinetic energy or the energy of motion of the wind, all right, converting that through your first energy transformation into mechanical energy, which then in turn creates the electrical energy. All right. So what it does is it eliminates the other energy transformations that occur before this. For example, in a coal burning power plant, you're talking about the potential energy, the chemical energy of that coal is then converted into the heat energy of the coal, which is then transferred into the water, which makes steam. Okay, so that heat energy is transferred into water, and then that water, then the energy turns into steam, and that steam moves at a high rate of speed, which is the kinetic energy, which then turns a turbine. So you are eliminating all of these, okay, and making it more efficient. Remember, there is no such thing as 100% transfer of energy. So as you lose a little bit of energy through each energy transformation, the fewer you can have, the better, and that's what wind energy does. Okay. So how does it actually work? Very simply, kind of what I just said here, where you take wind, the inflow of wind, all right, and you have your blades which spin and rotate, and as they rotate around, they're connected right here with the rotor, are connected to the rotor, which then turns the generator, okay, which creates the spinning of the generator, of the coil of wire inside the magnet. But to increase the speed, because the blades don't spin that fast around, so to increase that speed of the coil of wire spinning, you have a gearbox, okay, which is able to maintain the speed and increase the speed, so you get more electrical output. All right, so just a real quick explanation, nothing super important. I just wanted to give you a basic understanding behind that. Here's where I said, we're good, but we've been passed. There we go. We've been increasing in our amount of energy overall, but you can see at this point right here, all right, China has overtaken the United States in the amount of energy created by wind. So China now becomes number 1, the United States is number 2, and little country of Germany is actually number 3. And if you look at Germany, they're not far behind at all. So you can see who's been using wind energy, but you can also see that as every single country has been growing, the United States has grown dramatically, so has China over the past 5 to 10 years. It's just been a huge increase. That's why it is, again, the fastest growing renewable energy, all right, in the United States and in the world. All right, type of wind systems. You have small systems, which are for a house, and I'll show you what this is all about. You also have utility-wide, so that means you're putting and supplying energy into the transmission grids, okay? But you also have a community wind system where, for example, if a development comes in and you want to have them to be energy independent, they can generate their own electricity through maybe a natural gas power plant, a small one, and then add to it some wind turbines. All right, so you can do this on a whole different set of scales depending on what your needs are. So when you're looking at wind energy, the small wind system, you're talking about a home. All right, and in most cases, you're supplementing whatever energy you have coming in from the utilities. A lot of times they back it up with battery banks. And so what you do is when your wind turbine spins, instead of powering something in your home, it charges the the batteries, which then can be used later. The Connections building on the Save House actually has that particular system where the wind turbine charges the battery, and then we turn on the lights, the pathway lights at night, which runs entirely on the wind turbine. And also you can net meter, and by net metering it means that you can put energy or electricity into your home system, and if you don't need it, it actually goes back out onto the grid, and your meter, electric meter, will spin backwards, reducing the amount of energy that your home has used, meaning that you pay less on your energy bill, and you can sell your electricity back to the electric company. This utility-wide system, these are the big ones that you see across mountains and stuff like that, which we'll show you. And then, like I said, the community one is the one where you can actually, what I hope we're going to, create a small amount of electricity for a particular community or development or something to that scale. So there's a lot of potential here for different types. And here you can look at the different sizes of these. You got huge ones, which would be more on the utilities scale. And then you have all the way down to the small 10 kilowatt systems, which would be good for a home or something like that. This is utility one, where you see these, like I said, across mountaintops. You can see the size of these. All right, they can be placed in many different locations, create lots and lots of power, and at the same time, it can be a very beneficial energy system, because one of the things you'll notice in every one of these pictures, look underneath your power plant. In every single one, including the ones out in the water, the land below your power can be used and utilized. So a wind power system, one of the great advantages is you can actually use the land below it, and you can use it for farming, all right, or for, in the case in the ocean, you can put boats right around it. It's no big deal. Okay, so it does provide that benefit. Now, on more of a community size, this is a great example, and I like this one because this is actually Atlantic City. And if you look in the background, you'll see some of the casinos, and Atlantic City runs its entire wastewater treatment facility on wind, several large towers and turbines for wind. Also, wind turbines can be both horizontal and vertical. These are just a couple small scale ones that you can put up for your home. There's somebody who lives near Souderton, right outside of Souderton, which has the first one on the left. It has 3 of them in his backyard. But these are other possibilities. Or for your own home, you could talk about the one on the right. It's more typical, where you have a large tower with a small wind turbine on it. The one on the left, the little round drum-like thing, actually spins on the rooftop and provides you with a small amount of electricity. These are very small systems. They're even getting very, very innovative, where they're using the traffic, the wind created by traffic, to create energy over in Europe. So that's a possibility. And again, this is the utility size. The reason why I put this picture up, because this is in the Poconos near Wilkes-Barre, and you'll see the line of wind turbines going across the mountaintops, generating electricity on a large scale. Why are they on mountaintops? Well, by looking at this diagram, you will see that you want to create in a wind turbine. You want to place the wind turbine in an area in which the winds are fastest but steady. You don't want to create any turbulence or anything like that. So as winds coming up a mountain, down at the bottom or near the top of the mountain, okay, the winds become very turbulent. So you do not want to put a very low-lying, short wind turbine there. Wind speeds at the top, there's very little friction, and they're moving with no problem. But the best place, which is kind of interesting, is right at this location. And the reason why that's the best place is because there is some wind that has to go up and over the mountain, all right, and some wind which is steady straight across. And what happens is they kind of converge. If you notice, the lines get closer to each other. When they get closer to each other, all right, what that means is the winds or the air is moving through a point much faster. It's kind of like a river of water, where the river narrows. All right, the water's still got to get through that narrow point. Just as much water has to get through that then in a wide point. So the only way it could do that is by traveling faster. Well, the only way the wind can get through this point right here, all right, is by traveling faster. So you have a maximum wind speed right above the mountaintops, but not too high up, so you don't get that compression from the mountain. So you have a maximum or best location right here, where the winds are compressed and traveling fastest. And that's where you will see wind turbines placed. So there are strategies on where to place these wind turbines, not just in areas that are windy, but locally where is the best possibility. The top diagram here shows you wind around the house, so you'll see that on the left side of the house you can't put a wind turbine because it's just too turbulent. But if you put it at the top of your house, you have that exact same situation occurring where the lines of wind are being compressed, therefore you're going to have maximum wind speed. So the best place to put it is right near the peak of your house, right, just above the peak of your house. But more importantly, at the bottom is to make sure there's nothing in the way of your wind turbine to reduce wind speed, especially on a small size wind turbine. All right, how much have we been creating worldwide? And you can see every single year just more and more megawatts coming out of wind. So you can see why, just by that diagram, why it's one of the fastest growing. Where in the United States can we use wind? Well, this is probably one of the best maps I've ever seen, showing you the potential. Okay, and what I want you to see, and what's probably most fascinating about it, is that on the East Coast you have tremendous potential, meaning consistent winds that are strong but not too strong, as you're going to find out, but constant offshore. Okay, you can see in the Great Lakes you have that area also with the same type of potential, but then look at the large, big, huge area in the central part of our country, which may not be quite as good as offshore in the East Coast of the United States, but it's so large. And it's in an area where there are very few people. The population in this area is much smaller. Therefore, the NIMBY syndrome, not in my backyard, doesn't play in as much as it would along the East Coast of the United States. So, although the East Coast of the United States is outstanding and superb for wind, we also have that potential in the center of the country. Now, there are problems with having wind in the central part of our country because in order for the electricity to get to where we need it, it's very difficult. Let's face it. East Coast of the United States here, it's where most of our population is. West Coast over here, a large amount of our population. This area, not so much population. So if you're going to create a lot of wind and generate a lot of electricity of wind in this area, you got to create the infrastructure to bring it east and bring it west. Well, that infrastructure is very, very expensive. So even though we have tremendous potential, it's very hard to transport that energy out to where we need it most. So the ideal location would be offshore and then bring it on land. All right, but there are some impacts, as you're going to find out, about that. Tremendous potential. And you look at the states that have the greatest amount of wind energy potential. You look at Texas, Kansas, Montana, Nebraska, South Dakota, North Dakota, Iowa, Wyoming, Oklahoma, New Mexico. You can see that all of them do not have the population to really show the need for all this electricity. Now, Texas would be a slight anomaly on this, but the rest of that, you can have tremendous wind potential, but very few places that actually need it. So we got to create an infrastructure of power lines and a grid system that can pull it out of those locations to other locations in the United States. What about Pennsylvania, though? Pennsylvania, by potential, is only 22nd in the United States. So we have about 177 large turbines in 10 different locations, and we have more that are proposed. We are not the greatest state. I think this map gives you some perspective on how good our state is for wind. And you'll see that there are a couple locations. If you ever drive out to Pittsburgh, you will see there's an area right here in the Appalachian Mountains which is pretty good. All the brown spots are the best locations. And so when you drive out there, you'll go through an area along the turnpike which actually has wind turbines, and you'll see them off of the turnpike. The other place is up here in Wilkes-Barre and Scranton. You can see some brown up in this area, and that's where one of the pictures I showed you was located, up there. And if you look at us, sitting over here in Montgomery County, not so good. So we are not the best location here. So we're looking mostly at small scale individual homes, nothing on a utility-wide scale or community-wide scale. It just doesn't, we just don't have the potential. If I go back a second to this, you'll see I forgot to mention that if you go down to the southern part of the United States, Florida and Georgia, Alabama, Mississippi, very little wind potential. All right, so those areas are going to have to look to other types of renewable energies. So this is scattered in different locations. What are the benefits of wind energy? Significantly lower impact than our non-renewable. Zero emissions, no pollution whatsoever. Zero water use, something we don't think about when we talk about energy. We don't need to use any water for cooling or anything like that. We're able to use the land below, so it creates a very small footprint. It's an indigenous source, meaning that it comes from the United States. It's made in here, and we can just use it within the United States. It's sustainable, and it does provide jobs. There is maintenance, consistent maintenance on these. Construction jobs. All right, here they are building the blades on these giant turbines, just to give you some idea how big they are. Installing them at the top, you'll see that inside there is their little office and computer room inside. And people go up there every day and they check, make sure everything's working properly. Downside to wind energy, it's an intermittent energy source. It's not consistent. It still costs more than coal or natural gas. We need, as I said, the infrastructure to move the electricity from areas where there is a lot of wind to areas where we need the electricity. So that's a very, very expensive proposition. The only problem is, or the big problem is, that who's going to pay for that cost? And there are environmental impacts of wind energy. You'll see in a second both visual, noise, and wildlife population problems. So let's take a look at some of these downsides. First of all is winds are inconsistent. This is a graph of wind speeds over a period of 2 days, and you'll see that it's variable. You can see it going up and down and up and down, so it's not consistent. The amount of energy you make is not going to be consistent, and in fact you can see in this particular case, as it goes really high here during the day, late at night it drops down to almost nothing, so you're not making any electricity, and then it goes up the next day. So it's just too inconsistent to be a good solid supply of electricity. All right. Wildlife impact. They always talk about birds and bird fatalities, which is an issue. In this graph you will see, in this chart, you will see that it's not that big of an issue, although a lot of people make it out to be. Wind turbines are here. We're talking about 0.1 to 0.2% of all bird fatalities. All right. If you want to just go down the list, you can take a look at all these different things, and you can see what's the most dangerous to birds. Buildings and windows at 55%. So if we need to really take care and be careful about bird fatalities, we're going to have to remove all our buildings and windows. But yes, there is a problem, especially when you put a large wind farm. Now, a farm, when you hear the term wind farm, you're talking about many wind turbines put together, working together to create a large amount of electricity. If you have a wind farm in an area where there's a bird migration, okay, or a bird habitat area, it could cause some problems. So here you see a wind farm, all right, out west, and you could see the potential for harm as all of those wind turbines spin. Birds could be endangered by the turbines themselves. The other problem is if you farm the area below, farming attracts mice. Mice attract hawks. And so if you have many turbines in an area where hawks are trying to go down and get food, you're going to have some impacts. All right, but remember, the blades aren't spinning at a huge rate of speed. All right, so it's not like it's a blurred vision. Aesthetically, people don't like the way wind turbines look, and so therefore they don't want to approve them in many areas that actually have good wind potential. And the other one is noise. They do create a noise. When you're far away, about 300 to 400 meters, it's just a very, very slight noise. But if you happen to live close, or there's wind turbines, say in your neighbor's farmland or something, the large scale ones, utility size ones, when you get close to them, all right, they can sound like a lawnmower. They're that loud. Now, very, very few people are that close to them. All right, when you move away a little bit, maybe the volume of a vacuum cleaner. All right, and as you move away, now you're talking maybe 100 meters. Okay, a little more than 100 meters. You're talking about over a football field. It sounds like an air conditioner. And then as you move away, okay, this right here is the restriction of how close you can actually live to one, any type of residential area. Okay, and so you're outside that volume range, but they can be loud if you're up close to them. So the volume is an issue. The sound, I guess, is an issue, but not only if you're very close to them. And here's something very few people know about wind turbines, and that is you usually think that a wind turbine, as you increase the wind speed, it produces more electricity, but that is not true. A wind turbine, once you increase the speed, if you notice here in meters per second, all right, when you're talking under possibly 7 miles per hour of wind or 11 miles per hour wind, you don't make any electricity. It's just not strong enough. So you have to have a strong wind at a consistent rate, and as the wind gets stronger and stronger and stronger, the amount of production of electricity goes up and up and up until you reach a peak. Now this is for one particular turbine. Here is a line at the bottom for another particular turbine. You peak, and then if you notice, if the winds get too strong, your turbine starts to get too unstable and turbulent, and the amount of electricity produced goes down, or in this particular case, it goes to zero. It shuts off. So strong winds, like thunderstorm strength winds or hurricane strength winds, are actually bad for wind turbines. So it doesn't help to have super strong winds. You just want strong but steady winds, and you can create a lot of electrical power. Seeing this, you can see in this particular case how the fog is being pushed. You can see how the wind turbines are creating some turbulent fog throughout the wind farm there out in the ocean. And the reason why I wanted to show you this is because I think you can see from this picture there is potential for wind energy out there. And what is proposed may be controversial, but you're going to have to make a decision here. You know, we talked about how our offshore winds are some of the best wind potential for the United States, and it's also very close to large population centers. So there is a proposal by Atlantic to put out here off of New Jersey a series of wind farms. Okay, and also very large there. Okay. By the way, just so you know, right about here is Ocean City, New Jersey. Here's Wildwood down here. Okay, and we live up here in this area. But you can see all these, and then they're going to be connected to the shoreline by a series of electrical wires buried in the bottom of the ocean. So here you're talking about the Richmond area. Okay, here you're talking about lower Delaware. Here you're talking about central New Jersey, and of course up here in New York, where they will be supplied with this electricity from the wind turbines that are going to be on platforms like you see in this picture in the lower left, out in the ocean. There's a lot of opposition to this because people, as they lay on the beach, do not want to see these wind turbines off in the distance. But right now the proposal is trying to get through, and if it does, we could create over 6,000 megawatts of wind energy for the East Coast of the United States. But something you think about, because we see wind as a tremendous potential for our energy future. We can expand wind. There's no limit to how far we can go with wind. The question is, do we want to go with wind? And that's an answer that you will have to figure out as you continue to talk about and look at more energy solutions.